So today we are going to see how to write a map logic, how to write a reduce logic, and what are the APIs are involved in map phase and reduce phase, and how to call that mapper phase and reduce phase using the driver class. We'll call this one class as a driver class. I'll explain why we'll call this as a driver class. Okay. Before learning any language, before learning any language, we have to learn what are the data types will support by that language. Even if you remember in our Java classes, we have seen what are the different types of data. I mean, different type of data types. I can say the data type. What is a data type? What type of data it can hold, right? What type of data it can hold, or what type of data we can represent using that specific data type. In Hadoop also we have some set of data types. In Hadoop also we have some set of data types. The Hadoop has its own set of data types, I can say. And what are they? How to use them? We're going to see it. Okay, let me share my screen. Are you guys able to see my screen? Yeah. The data types are, if you go with the C language, what are the data types are there? Int for the numeric, float for digit number, you can say decimal numbers. We have a character, we have a boolean, int, float. I think long also will support the C. Long is there, right? These are the data types. When it comes to Java, we have the same type of data types. It is a int or integer object, float or float object, double, so small d, or double. It has long, it has a long or long, and it has boolean, the same way boolean, and it has for the character array, we have a char or we have a character, the same way we have a string as well for the character array, right? The same way when it comes to Hadoop, there are set of data types. What are they? To support integer data type, we have int writable. We have a int writable. To support decimal type of values, we have a float writable. To support long value, long writable. To support double value, double writable. To support a string, we have a text. We don't have a string directly here, we have a text. To support boolean, we have a boolean writable. Right? These are the most of the. There are one more map writable for map type of values, and we have one more null writable for null values. Okay, these are set of data types for to store or to hold or to handle different type of data. Clear, guys? Why it is writable? Why it has its own data types? Why can't it use Java data types? Why can't it use Java data types? Or why it is using its own data types? We'll see them in a later point of time. Clear, guys, about these data types? Then try to implement or try to understand how to write a logic for map phase, for reduce phase. We'll be taking word count program as a hello world program of Hadoop. Okay, we're going to take a hello world program of Hadoop. What is a hello world program of Hadoop? Which is a word count program. Which is a word count program. If anyone wants to take note of them, int writable, float writable, long writable, double writable, text, boolean writable, map writable, and null writable, you guys can take them. Okay, then let's try to see. Yesterday we have seen there is a mapper class. Then before going to see them, we are going to see what are the APIs are available for mapper phase, what are the APIs are available for the reducer phase, and what are the methods, how we will implement them. If you see here, we have a we have a mapper class. We have a mapper class. What this class is doing? It is taking, these are the generics. Actually, these are generics. Okay, the generics, you can represent what are the type of values your class accepts, and what are the type of values it will give as output. We can specify them using generics. Here my mapper class, which is given by Java API or Hadoop API, that is key value. It means that it will take input as a key value and it will give output as a key value. Using generics, you can specify what type of variables your class will take and what type of variables it will return as part of the your tree. You can see here, I think I'm not able to see any of the value. Fine. And you have a setup method. We'll see setup method in detail later point of time. And we have a cleanup method. We'll see this setup and cleanup method later point of time. And your mapper class will give, these are the three major methods. These are the three main major methods which your mapper class API gives you. You have to override while you are writing your mapper function or mapper phase. While you're writing your mapper phase, these are the three methods. These are three important methods or important methods we have to override in our custom mapper class. If it is not custom mapper class, it means that it will use the default mapper class. If you are going to write your own mapper class, you have to override setup method and cleanup method, and you have to override this map method. The map method is a main important method, and setup and cleanup you can write your own or you may leave it. Depends on the requirement. We will go with the setup and cleanup methods. We'll see when we'll go with the setup and cleanup methods. Your setup and cleanup method will get called only once in the life of mapper phase. But your map method will keep calling. Guys, how many times the map method will get called? Yesterday we have discussed. How many times the map method will get called? It depends on
number of records line split.
Yes, number of records in the input splits. But your setup and cleanup method will get called only once. Your setup method is for the setting up the environment. Let's assume that you need to take some. It's kind of initialization. It's kind of setting up your, what are the variables you are going to, not kind of variables, like what type of resources you are going to use in map phase. The cleanup is if you open any resources like your file, file input stream or file output stream, you have opened some out streams. So those streams will clean up. In the cleanup, we'll close them. Setup and cleanup will get called only once in the life of the mapper phase. Setup will call before calling the mapper method, and cleanup will call after completion of the mapper method. Clear, guys? Try to understand what are different methods in the mapper class. Then your map method will write our own logic here. And forget about this run method. This run method will get called by your framework. Your run method will get called by your framework, and your your framework itself will hand over the key value page. Next key value. What is the next key value? Where it is there? It is there in your record reader. Where it is there? It is there in record reader. You just go ahead and see here. Next key value. What the next key value will do? While reading the input split, we got the input split. Now we have to read the input split. Who will read the input split? The record reader will read the input split. The record reader has set of methods to read the your input split. In that, one of the method is next key value. What it will represent? Whether it will return true or false. It will return only true or false. It will not return any value. It will return true or false. This next key value method, what it will do? It will check whether still I do have a key value pairs or not. Like your has next method has more elements, has more elements we have seen in the iterator classes, right? The same way here. Next key value, what it is doing, if you try to observe this logic here, it is taking the keys and all has been assigned in the before. Here the keys, one second, these are the keys, and key and values are the global variables. On position, start position, end position, maximum line length, these are all global values. These values will be initialized in the initialize method. And in next key value method, what we are checking, the key should not be a null. If it is null, we'll just creating a key object. This dot create this new object is a fresh object it has created, and we are setting the position. And if you see here in the loop, we are reading the complete the next set of the whether the in the input split is there any key value pair in the next in the input split. If you have a if new line equals 0, you just break, you just come out. So it is checking here. If it is 0, it will return false. If it is not if it's not 0, if it's more than 0, if it's greater than 0, it's like a size of your input split. I mean next key value pair, and then it will return the true. So when it return true, it means that your while loop get true, and it will go to the map. This map method will execute. From where get current value is getting? From here only. If you go and see get current key, your record reader will give the current key, and your record reader will give the current value. Okay, these current key and current values are coming from your record reader. So what does it mean? Your record reader will read each record at a time, and it will take the current key, and it will take the current value, and it will calls the main method, your map method. So ideally it's a main method for your mapper class, your map method in the mapper phase. Then your logic, what are the logic you have written here, it will start executing them. And also yesterday we have seen identity mapper, identity reducer. When you didn't write your own mapper, when you didn't write your own reducer, the default mapper will get called. That's what I have explained, right? See here, this is the default mapper function. What it will do, it just emitting what are the keys coming, what are the values coming. What are the key value it is taking, the same key value pair is emitting. It is not doing any other logic. What are the key value you give to me, I'll return that as output. In the same way, your reducer phase also will see that in. Clear, guys? You guys understood how it internally works? If you know how it internally works, it is very easy to implement. Okay, let's go back to our slide. Now, let's see. This is what we have seen. Input split will give the key value pair to the map function. Your map function will process it and give as output as an intermediate output. It calls intermediate data is a key value to the reducer. Then reducer will finally return the output of that. Now let's see your map abstraction. What is a map abstraction? What we are going to do in a map phase. It is the input key value pairs it will give. Who will give? Your record reader. Key is a reference of the input value. I mean the input key, the data's either if you take in the default text input format, that is key is the offset and value is the rest of the line. Value is a data set on which to operate. Which to operate means which data you are going to modify and which on where your logic is going to apply. And evaluation, you will map phase. We have to return our own logic on the map function, and it produces the key value pair as the output. We're going to see how we are going to override, and before going to show them, I'm going to show you here how it will work internally. If you know how it works internally, the going forward will be simple and it will be very easy. Clear, guys? Next, see, this is the example. I mean, this is kind of the skeleton. It's called a pseudocode. Okay, I'll define my map method. In the map method, I'll be having the key value pairs, and I'll take the key value pairs and loop through values because I need to handle all the values, right? I loop through the values and I'll start doing some operation here. Okay, a small example. And reduce phase. Whatever the intermediate data has given by your mapper, it will start reading them, and we'll write our own logic. That logic will apply on the in the reducer phase key value pairs, and will start emitting the output. Okay, the output also come as a key value pairs only. Try to remember that. Try to understand that. Even your reducer also give output as a key value pairs. Okay. Typically, it's a function which will take a key value pairs, each key value pair from the your mapper phase, and it will also process it internally, and it will gives you the output. And this is the example for it. We'll take the reduce as a key value pair, but try to understand here. Your reducer will take list of values, not the single value. It will take list of values because in between your mapper and reduce phase, there will be one more phase called shorten shuffle. The shorten shuffle, when it's execute the shorten shuffle, the values will become list of values, not the single value. It is kind of array of values. I can say it's array list of values or collection of values, not the single value, because multiple mappers are executed, and the shorten shuffle, what it will do, the reducer will be only one. The mappers will be launching on the each input split, but the reducer will be one or two, or depends on our requirement. I mean, depends on our data we are going to specify. But mappers will be very limited, not the number of mappers. Sorry, reducers will be very limited. Your mappers, how many mappers? Who will decide? Number of input splits. Number of input splits equal to number of mappers. When it comes to the reducer phase, you can specify how many reducers you want, or by default there will be configuration map_reduce.tasks. You can specify one, or by default it's a one. You can specify more also. That case, the sort and shuffle, what it will do, it will sort the values on key. Whatever the output came from your mapper, all the keys it will take. It will sort the global sorting. That's called, guys. Try to remember here. It's a global sorting. It will take all the outputs from all the mappers, and it will sort them, and it will hand over to the reducer. And when it is sorting, it will also group the values. Let's assume that the key called mobile, okay, and mapper 1 is emitted 10 mobiles, mapper 2 emitted 100 mobiles, and mapper 3 is emitted 50 mobiles. Now mobile is the key, right? Let's assume that mobile is the key, but count is the values. The key is sorted, and the count will be grouped as an array of values or list of values. Those list of values we will iterate here. In the reduce phase, we'll iterate one by one. Here, we'll iterate one by one. We'll see that in detail with an example. Okay, this is how it will work, the whole flow. Okay, let's see how it will work. Yeah, this is complete phase of this is my example. Yeah, we are going to write an example, then I'll explain the slides, these details. Okay, now before going that, please, we're going to see the setup. Parallelly, you guys also do the setup. Okay, I'm going to do a setup for map reduce framework in my Eclipse. uh, it means that logic will going to write in mapper all aggregation iterations parties and reducer. Yes, correct, Chendu, your understanding is correct. Now try to see I'm going to set up my environment. I'm going to set up my development environment. You guys also follow the same steps. New project, Java project. It's a Java project only. Are you guys able to follow me? Guys, follow the same way. New Java project. Give some name for this. The project name. You can give any name for this project. I can say Hadoop hands-on. Hadoop hands-on. And leave it, the rest of the things will be same. Go next. Your source, after compiling the code, will be the bin directory. Let it be, you don't need to worry about it. You just finished. Open. Yeah, it's a different kind of perspective. Mine is a different kind of perspective. So I'm taking core Java project. By my perspective is J2E project. You say yes. Okay, now you got the this project. You guys completed it till this step? Are you guys completed till this step? Are you guys created the project? Please respond quickly, then we'll see the next step. Are you guys completed the first step, creating a project? It's very simple. You just code new Java project. You just give a name and finish. Guys, are you guys did it or not? Right click on the your one more time I'm showing here. Right click, new Java project. Right click, new Java project. Give the project name. Then click on the finish. Then click on the finish. Is everyone done this step? I'm going for next step. Or you guys want? I'm going to show the next step. Do you guys want me to wait, or you guys are doing? Okay. Next step is we have created the project. Now we have to set up the build path. Build path means what are the jars and what are, see, Hadoop is a separate, right? It's not a default Java. It is a Hadoop is a separate libraries. Hadoop has its own libraries. We need to take those jar files. We need to take those libraries. I can say we need to take those APIs. We need to keep them in the build path. If it is a Java, you don't need to keep anything by default. It will take the Java build path. I mean Java libraries. You see here how to create. I'll show you the simple step here. We'll also follow the same kind of step. Right click, right click on the project, select the project, right click on the project, go to build path, go to build path, go to build path, click on the configure build path, click on the configure build path, click on the configure build path. You'll come to you'll come to properties for your project. You'll come to this window. In this window, instead of adding all the libraries here, what we will do, we will add user library. We'll add a user library. Are you guys are following me? Click on add library. Click on add library. Click on add library. Select user library. Select user library. Select user library. Click next. Click next. User library. Click next. After clicking next, here you'll be having empty, but I have one already library. You'll be having empty wala. Okay, and click on user libraries. Click on user libraries. Then click new. Click new. You can give. I'm giving new because already I have a one library. X. You can give 1.2.1. You can give any name. Okay. You can give any name. I'm giving Hadoop 1.x. Hadoop 1.x. Are you guys following? Then say OK. Select this. Whatever you have created, select that. Go to add external jars. Go to add external jars. Click on add external jars. Click on add external jars. Don't close it. Okay. First, after creating your library, select that. Select that. Click on that. Go to add external jars. In that, go to your where you have installed your, in your case, user slash local slash Hadoop. Inside the Hadoop, you have a Hadoop, right? You have a Hadoop. You have a Hadoop project, Hadoop home directory. Go there, you will find some libraries, some jar files. Select all. Click on one of that, hold the shift key, click on the last one. Select all. Save open. Save open. It will get add under your user library. It will add under user library. Again, click on that. You can make it minimize if you wish. If you don't wish, you can leave it like that. You click on again the user library, click on add external jars, go to your home directory again, click on library libs. Where is that? Click on libs and you'll find the so many libraries. You'll find the so many libraries, so many jar files. You can use Control A, select all. You can use Control A. You select all of them, just click open. You just click open. You don't need to every time, you don't need to minimize this, guys. You don't need to. All will get added. All of the libraries will get added. And also I don't think anywhere any other will be there. That's it. I think there won't be any other libraries. All are we have added all of them. Okay. Just say okay, and now your user library has been selected. Select the user library. Finish. Select the checkbox. There will be a checkbox. Select that. Click on finish. When you click on finish, you'll come to the back other window where you'll get the Hadoop, whatever the library name you have given, and click OK. And click OK. Till here, you guys are done. Are you guys done the setup?
Ravi, I mean to add this, to create this Hadoop -1.x,
Mm-hmm.
we should right click on the project and say what new source folder, correct?
Oh, still you are that step. See this here. I'm going to do one more time. Okay.
Yeah.
Right click on the
Yeah.
project, build path.
Okay.
Okay. Go to configure build path. Configure build path. Because
Yeah.
we are going to create a first fresh build user library. Okay.
Okay.
After you got this window,
Yes. 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 I got that.
then go to add library. Click on add library. At right hand side, you'll find the some tabs. Click on add library
Okay.
and you select user library and you
Yeah.
select
Done that.
go to next step and you'll be having empty here, right? You don't have anything
Yes.
here. So click on
Yeah.
user libraries. Click on user libraries
Yeah. Yeah.
and
Done that.
create new. Here you don't have anything, right?
Yes. Correct. That is
Create,
empty for me. Yeah.
yeah, create new and give the name.
Yeah.
And after giving the name, it will appear like this.
Yes.
Select that and at right hand side you'll have a add external jars. There is a button called, there is a the option called add external jars. Click on that.
Ah. Yes. That is. Yeah.
Click on add external jars. Go to your home directory wherever you have installed Hadoop, right? You have installed
Yeah.
Hadoop, right? Go to that home directory. Inside that you'll find some these jars: Hadoop client, Hadoop core, Hadoop ant, Hadoop examples, right?
Yeah.
So all this is
Yes.
select all the jars. Say open.
Okay.
Now it will get added here under this.
Yes.
Now again select the user library. Again select your user library name. Click on that name. Again go to add external jars and go to lib in home your Hadoop directory. You have a lib directory, lib directory.
Yeah. Yes. I know.
You have a set of jar files. Select all of them. You can say Control A. Select all of them and say open.
Okay. I added them also.
All will be added. Then say OK.
Okay. Yeah. Yeah. Done.
Okay. After that, here it will come. You select the library.
Yeah.
You select the check
I
mark.
selected.
Then say
Yes. I
finish.
done.
When you say finish,
Okay.
it will come here. Then you say OK. When you say OK, it will get added into your project's build path.
Yeah.
It will get added into your project build path. Now your project is ready to write any Hadoop code.
Yeah. Yeah. Done. Done. Yes. Yes.
Done,
Done.
right?
Yes.
All other guys also done this the same step. I mean, same. All other guys also did the same. Please respond to me. Then I can understand whether you are following or not. My intention is that if you are not able to follow, I want to explain one more time.
Ravi, my system is slow. I've noted down the steps so that I will do it later.
Okay, good. Okay, fine. Fine, Ramya. What about the
Okay.
Sri, Rama, Mani, Jay? Okay, fine. Now, now go to your SRC folder. Create one package. Com dot. You can give any name. I prefer to give Hadoop, or sometimes I'll give my own name. Um, I'll say jobs, or I can say job. I will set up if these steps are in the document. Okay, Rama, actually these steps are not in the document. Prepare one document today. I'll upload into our drive, so you can take it. I'll prepare this all the step by step these steps on a document. I'll upload it. Okay, then create a package. Finish. Go here. What we are going to do? We are going to create a mapper class. Right? We are going to create a mapper class. Before that, we should ready with the data. We should ready with the some data. Right? Let's go take our text file. Take any of the text file. Put some data here. You can get the data from. You can type yourself, or you can Google it. You can Google it. Hadoop Wiki. Go to Hadoop Wiki. Hadoop Wiki. You can copy this content. You can copy the content. I'll copy some content. Copy this, any of the content. Okay, what are the content you copy that, go to a text file, paste it, paste it here. If you see, my editor is telling me this whole is a one line, this whole is a one line, the whole thing is one line, this whole thing is one line, right? So in your case it may different. Now save this. I'm saving into desktop. I'm saving, say, sample data .txt. I have saved it. Actually, the data has to be there in HDFS. We'll still not yet keep the into HDFS. We are keeping in the our local machine only. Let's go back. Let's go back to our project. Now, right click, new class. We need to take a new class, right? I'm going to say word count mapper. Word count mapper. In this, I don't need main method. I don't need main method. Okay. Here, what will be my superclass? What will be my superclass? Okay, we'll do the extends from here. We'll do extends from here. Extends, because I need to take the mapper class, right? Extends mapper of, can use this, import from, let's see, from where do you have to import? Import from Apache Hadoop MapRed. Import from Apache Hadoop MapRed. Then here you say what is your key input, because I'm going to use, I should know what type of data I'm going to handle. So I'm going to handle a text type. So my input will be long writable, and what will be my output will be text. I mean, not input of value input, value input. It is should from Hadoop IO. It should be from Apache Hadoop IO. Now, then what will be my output? My output will be word counts, right? What is the problem statement? First, try to understand the problem statement. This is very much important. Whenever if anyone assign you work, or whenever if anyone is ask you to write some logic or ask you to write some, they have given some data and ask you to process it using MapReduce or Hive, whatever it is, we'll try to understand what is the data. Understanding data means what is the format of the data, what type of data it is, what is the delimiter of the data, what is the what are the analytics I'm going to do, what are the statistics I have to generate out of it. In our case, the word count. In our case, word count. What is the word count? I need to find out the how many times came, Hadoop how many times came, distributed how many times came. I need to find the words, number of words in my file. So, and also my file is a text file. So if it is a text file, what type of input format we have to go with? Text input file format. Text input format, right? We have to go with the text input format. If I'm going to text input format, I have to design my, I have to first design my key value pairs. I have to specify what is the key. I can say key one. I can say what is the key I'm going to give and what is the value. This is very much important, guys. You need to understand. First, you need to understand the data. Then you need to prepare what type of key it is going to be. In key in, I'm talking about key in, value in, key out, value out. So my mapper, what is the key? What is the value? What is my key to? You can say key to. Key to means key output. What type of key it is, and what is the value of out value, value to. What type it is. In your case, I can take int writable because I'm going to handle with a huge amount of the data. The offset may go beyond the integer range. So I'm going to take a long writable. And value will be, because it's a line, because it's a text, I'm going to text. I'm going with the text input format. And so what is my what is the analytics I have to produce out of it? Words and number count like 23 or 100. This is the count I want to do. Final output I want word and count. So then what I have to emit here? Text. I have to emit text because my words are text, right? So I have to emit text and a number and number. It can be long writable or it can be int writable. Depends on. Okay. Now this is my mapper part. I have designed my mapper part. This is my mapper part. Then what is your reducer part? Also we need to design. Now I'm going to design my reducer part. I'm going to design my reducer part. What is the reducer part? It has to be same as this, no? Whatever your mapper output is equal to your reducer input. It should be equal. And what you are going to emit is key 3. Again, it's a text. And value 3. Again, it has to be number. It can be integer or it can be long writer. Clear, guys? Depends on the problem statement. We have to prepare. Depends on the problem statement. We have to prepare a key value pairs. It is a problem statement. I need output. as word and number. Like let's say Hadoop 100 times. Let's say HDFS 200 times or 2000 times. I want the output like this. When I want the output like this, I have to design what I have to identify what is my key and what is my value. Is this point clear, guys? Whenever you see the problem statement, try to understand the data, try to what the output I have to give, final what is the final output I have to give, and according to that, what will be your mapper logic, mapper key value pairs, and what is your reduces key value pairs. We have to decide them. What can I take as a key and what can I take it as a value? What can I give as a key as a output and value as output? And what will be the reduce? This will be known. This always should be same. This will be always same. You don't need to worry about it. And what will be my reduces output? So we have to design them. Clear, guys? If you understand this, it will be very
Yes, Ravi.
yeah. If you understand this, it will be very easy. So easy to implement your logic. Now my key is long writable and values. If you go with this, if you see that, if you if you see that my is long writable and text and int writable. It can be int writable. It can be long writable. Again, text comma int writable. Right now, I have to override a map method. I have to write a override a map method. Okay, your map method will take key, value and context. You don't worry about this, what it is representing. I'm taking a context variable of mapper. Let's see here. Oh, again it is giving some problem. We have seen it right before. Go to your mapper class. Here we have a context. This context we are making use of it, nothing else. This context we are making use, that's what it is representing. Okay, so you don't worry about it, you just blindly you can specify it is a context. You can remove this, you can remove this. Okay, and one more thing, you try to understand here, you try to understand here where your map method is there. Your map method is throwing, your map method is throwing in exceptions. One is interrupted exception, one is IO exception. Why IO exception, why interrupted exception? Because it's an input output exception. So we are going to take input as some key value pairs and we are going to give some output as a key value pairs, which is handling with the data. The uh, data will be in the form of input output objects. Right, there may be a chances you may get input output exception. And why it is interrupted? Because we will be launching the child JVMs on the input splits, right? And there may be a chances where other thread command interrupt, other thread may command interrupt that data or that process. Where let's assume that there are two input splits. One input split needs to talk to the other input split for some other, not ideally it will not talk because input split itself is a independent. Sometimes you may need to talk to some other data node, or sometimes you may some other thread may work on it because it's kind of parallel process, right? So there may be chances who may disturb your process. So that is the reason they're throwing interrupt exception and IO exception. But here what they're doing, it's throws. Throws means they don't want to handle it. That is the reason they didn't write try catch here. But whoever is calling me, who is calling here your run method, whoever is calling me, they have to handle it. They try and finally. We have seen this the same kind of things in our exception classes. Your map function don't want to handle, and whoever is calling him, they want to handle. They're handling here, but they're not throwing an exception. Simply exception comes and then exit. They're not. They're ignoring the exception. Okay, they don't want handle. Whatever the exception comes, let it come. I don't want handle. And here also they don't want to print anything. They just And also if you see your run method, if any exception occurs here, your run method also throwing to framework. Your framework will display, or whatever the operation they have decided, that will be displayed in the console. Clear, guys? There is our word count mapper. Go back. Now I don't need these two lines of code. Remove it. Now I understood what is my input key and what is my input value. Now try to, it is a overridden map method. It's a override, right? It's a overridden one. Now what will be our logic? What we are going to do with that? What is your input here? Input will be, key will be offset, and value will be line of the complete line text, right? So we are not going to worry about the offset. We don't need it. We need only the value. We need to worry about the value. So let's take string line equal to value dot toString, because the value is a text type. The value is a text type. The text type will not understand your Java. That is the reason I have converted into toString and I'm storing into string. Okay. Now what I need to do, I need to split the line, right? I have taken complete, have taken complete record. Let's assume that from here to, let's assume that till here only for time being. I have taken complete line from here to here. Now I need to split it. Now I need to split this record. How will I split? By based on the space, because I want to take the words. I want to take a single words, not the two words. I want to take each a single word. So when you want to take each single word, we have to split with the space only, because each word is separated with a space. Now go here. Either you can use a string tokenizer, or you can use split method. You just specify line. If you didn't specify any delimiter, by default it will take space. By default it will take space. Now what is the next step? Now we got all the tokens here. Now we have to go with while tokens dot has more elements. If it has a more elements, then what I have to do, my actual logic will comes here. Now your Java understands strings, but Hadoop understand the text, right? Your Java understands strings and Hadoop understand text. Now whatever the word I'm taking here, I need to put into the words. I need to put into the Hadoop understanding language. For that, I'm creating one global variable, text word equal to new text. So what I'm doing here, word equals tokens dot next token, or next element dot toString, but I cannot assign like this. What I have to do, I have a method called dot set. Whatever the token I'm taking here, I'm setting into word. Now it will go with each word. Each word will be setting into the word. And what I have to do here, I have to emit it. Context dot write. Context dot write means we are giving us, or we are emitting as output. Context as write. So I have to emit as a key value pair, right? What I have, my key is text and value is int writable. So you can take your key as word and value as, you can say, new int writable of 1. Try to understand here why I have taken 1. Here what I'm doing, I'm splitting the whole word. I'm taking the word comma 1. Let's assume that I got the Hadoop 1 and I got the other Hadoop 1. I'll be emitting like this, and HDFS 1. Why? Because let's assume that it's a map 1 output. It's a map 1 output. You may have map 2. But also the map 2 also may have the same words. Hadoop 1, HDFS 1. And we also have the map 3 also will be having the same. After the map, as I said, a short-term shuffle will happen. Short-term shuffle phase. What it will do in the phase of the short-term shuffle, it will sort on the based on the keys. Like here in our case, let's say here E is also there one time. So let's assume that here let's just say A also there one time. Then it will sort A array of array of it will it is sorting. Now the sort and shuffle phase. It will check. Let's assume that here also A is there one time. Let's assume that where one more time came. It will sort A. It will count how many times. Here one time came, comma, and here one time came, comma. Here also one time came. It will decide like this. A came these many times. Now Hadoop. Let's take Hadoop. How many times came? It's also 1 comma 1 comma. Here also 1. In the sort and shuffle phase, it will happen. It is sorting on the keys. These are the keys, no? It is sorting on the keys and grouping on the values. We'll see in more detail. We'll see in the how it is happening internally. For the time being, you just try to understand. It will happen in this way. HDFS. Now HDFS how many times came? Here one time came. Array of one time came, comma. Here also one time came. Now this is my short and shuffle phase output. This output will go to the reducer. This output will go to the reducer. Why I have taken 1? Because I need to count the total words. If I say only here only 2, but again it is each iteration, right? Each iteration. Whenever it calls once, the map method call once, I may not be having a control of the previous iteration. So when now the A came thrice. When a shuffle is happened, now I know that it came 3 times. I can just go ahead and sum this in the reducer phase. Now I can see my reducer is 3. I can see my HDF is 2 times. Right? That is the reason we're emitting as a 1 stamp. Okay? Clear about this? I'll explain in with our detail how it will be split and how it is working with a diagram. I'll explain that. Okay? And today just see the logic of the, someone has some doubt. Okay, we'll just see the mapper logic and reduce logic, the complete flow, the execution of the reducer. We'll see tomorrow. Actually, I thought to finish both in the same day. I think it's already 7:30 now. Um, it may it may not able to finish. We have to go with the reducer now. Create a reducer class. Word count. Word count. Reducer. We don't need the main here as well. Just say finish extends extends reducer, which is come from here. It is expecting what is the key. Here the key is text. The value is, we need to import it. Text. And what is the value? Value is coming as list of values. Iterate of values, right? Value is iterable, and here text, and here long iterable. Go here, go with the reduce method. Say it is a key, say it is a value, say it is a context. If you see here, it is a collection of iterable of values. Iterable means it is coming as a collection. How it is coming? Why it is coming as a collection? It is coming as a collection like this because there in between the sort and shuffle phase is there. It is giving as a array of values. It is giving as array of values. So that if you want to traverse through array, or if you want to traverse through a list, we should have an iterator, right? Iterator and interface. So here we are taking iterable. Iterable is the parent of all iterator, list iterator, these classes, these interfaces. Now go ahead and implement your logic here. Take sum equal to 0, sum equal to 0. Now we didn't understand this value. So iterable or iterable. I need the key. I need to convert the key into text. I don't need to convert. I'll take the same key. Here you write while value dot value dot iterator dot has next. Go here, sum equal to sum plus dot next. Why it is undefined augment? Okay, it's int writable. We need to convert this into dot get. We need to convert into, because it is int writable, but we are putting into int. Or you can take it as a long. We'll take int only because sum will be less. Okay. Now after each iteration we need to emit context dot write. What is the key? Keys, keep it key like that only. Whatever the word comes, the value will be sum. Here the sum is int type. I need to convert into int writable. Now output is, we have taken long writable, right? New long writable of sum. This is the logic for your mapper and reduce. Then there is another class which is called driver class. Who is that? He is a driver class. Actually, that class will be having a main method that's called word count. You can say, instead of saying driver, word count job, because in the Hadoop we'll say it's a job class. You can say it's a driver class as well. Okay. Now I need it main method here. Okay. Here I will extends configure configurable. It's an implement interface. I think it's an interface. Hadoop configurable. Add unimplemented methods. To set conf get conf. We'll see them detailedly. No, this is extend tools and implements configurable. Extend tools. Let me have a look at this. What is my driver class? I have the driver class here. I can take it from here. Implement tools. No, we can extend the configurable also. I can be just implementing the tool. We'll implement tools. We don't need this. One second. Yeah, it's configured. Yeah, this class I didn't remember. It's a configured class. Go to word count. It's a configured. It's tools. Sorry. It's tools. Extends GURD. It's configured. It is a configured. It is a configured. This one. Yeah, I got it. Now go here. It is from how to put it, and implement unimplemented methods, which is a run method. Let's say aux. Now create a configuration object here. Configuration conf equal to new configuration object. Let's say conf this dot conf equal to conf and here return conf. Here we have to call tool runner dot run method where you'll give a configuration object, where you'll give the your job, word count job, and where you'll give the arguments. What are the arguments comes from here? We'll pass the arguments. So we'll see the rest of the logic tomorrow, and we'll execute the complete program, and I'll explain you how it is getting splitted into keys and values. We'll see tomorrow. Is this fine, guys? It's already 7:45. We'll see the driver class logic tomorrow. So if you guys have any doubts, please stay back, or others can leave for the day. Okay. Clear, guys? Yeah. Thank you.
Kira?
Yeah. Tell me, Chandu.
I I have one question that
Why it is
why it is
having?
having own libraries and framework Hadoop. Yesterday I asked you the same thing, but this is the correct question.
Okay. So Hadoop is a different framework, right? It is not like which is come with Java. Hadoop is a separate framework to handle the large amount of the data, to process the large amount of the data. So
Okay.
then, if you say why Java has its own libraries,
Yeah. Yeah.
why Java has its own libraries, or why .NET has its own libraries, why C has its own libraries.
Why means to having of
Understand, right? What I'm trying to explain.
yeah, yeah, yeah.